Welcome to Guino7.com. Please like and share and subscribe my video. Today we're going to look at the dynamic equilibrium. You have done the reversible reactions in the previous video, and so today we're going to look at how in the reversible reactions equilibrium can be established. Some of them will actually can go backward direction. Those type of reactions are called reversible reaction and represented by two half arrows. Now, in dynamic equilibrium's definition means the rate of forward reaction is equal to rate of backward reaction. So when the rate of forward reaction is equal to rate of backward reaction, that is called dynamic equilibrium. How it's going to happen? For example, at the start, let's just say number one position is you have A plus B. Now A has that much, B is that much, is going to make nothing at the start, zero product. After some time, you will see A has gone this much and B also reduced a little bit. And this time you have made C plus D. You have made some of it. Then in the third position, you saw A has gone even smaller, and then you have got C plus D also has kind of same concentration. So we can just make it a little bit more smaller just to make sure that this one is a little bit bigger. So you can see that at this point, the amount of reactants, you can see that the rate of forward direction, whatever you're making, doesn't matter how many moles you're making. So if you're making 3 moles on the forward direction, there are only 2 moles. If you're making 2 moles of C and C plus D, you're also making 2 moles of A plus B. At this point, when the rate of forward reaction is equal to rate of backward direction, that is called dynamic equilibrium. You're not going to understand if I don't use this example of stairs. Imagine this young man here is running actually onto the stairs. You know, when you go for shopping. If he is actually running faster than these stairs, he can climb up. If the stairs are going this way and he is going that way, and their speed is going to match to each other, he's not going to travel any distance. So he's just going to move on to the same position for don't know how long, but as long as their speed is correct, speed matches each other, he's not going to go on the top of the stairs. If he is slower than the speed of the stair, the lift, what's going to happen here is going to actually go backward. Same goes here. If the rate of forward direction is equal to the rate of backward direction, then there is no problem in achieving the equilibrium. They both are equal. Suddenly you realize that the guy who actually did that, his name is Le Chatelier's. Le Chatelier's principle is very famous to understand altering the conditions. There are so many conditions you can alter to check the effect of them, and you can see my first video that what will happen to the rate of reaction. Now when you look at this equilibrium and you have established the equilibrium, you realize I'm going to increase the concentration. Increasing the concentration of A plus B. If you increase the concentration of A plus B, the reaction will move to the forward direction. So the reaction will be forward. Means you will make more C plus D. More C plus D will be produced until they have got the same rate. Because you change this side, you increase that side. So automatically the reaction will go into that direction. If you decrease the concentration of the reactants, the reaction will go backward, right? So decreasing the concentration of A plus B, the reaction will go backward. Why? Because it is going to balance the rate, because now you have disturbed the equilibrium. Equilibrium is when the both speed are matching each other. The second part of Le-Chatelier is, for example, you have A plus 2B making, let me just take a real example rather just using playing with the alphabets. You have nitrogen reacting with hydrogen and producing ammonia. For example, if you are going to change the second one is actually pressure. If you change the pressure onto this, Le-Chatelier said, if you change the equilibrium, or if you change the one of the factors, the reaction will oppose that change to counter the change you have done. So the equilibrium will shift either left or right to counter the change you have introduced. One of the change was increasing or decreasing concentration of any one of them, and the other is actually pressure. Now when you increase the pressure, you need to understand that all of them, you have H2, N2 and NH3. You have all of them in one container. This is what people do not understand. Because they all are present in one container, what's going to happen there is, in chemistry, the reaction is only going to happen when the particles collide with each other. When particles collide with each other, then the reaction will happen. When you actually increase the pressure, you are reducing the space. If you have looked at my previous video, you reduce the space. When you reduce the space, what's going to happen there? Particles will collide more, reactant and products. They both collide with each other. What's going to happen is here, you have 3 of these and 1 of these. On the reactant side, you have 4 moles, or for a simple language, you can 4 molecules. Here you have 2. When they both collide with each other, they make ammonia. Now, when you have increased the pressure, you have more chances of hydrogen to collide with nitrogen because they are higher in number. So, whichever side has got a higher number, the reaction will go into the other direction. So, N2 and 3H2 both will collide with each other more. So, by increasing pressure, you will make more ammonia. And the reason? Reaction moves in that direction where you have less number of particles. And how are you gonna look at the particles? Not with this number, by this number, the big number written in front of them. You have 4 and you have 2, so it will go in that direction where you have ammonia. If you reduce it, it will go backward. Okay, reducing the pressure will take it backward. Now the third part is very crucial, which is actually, I'll do it here, is temperature. Now the temperature has got a different effect. Why? Because you can have exothermic reaction and you can have endothermic reaction. So temperature will have a different effect on both of them. So what's going to happen? This one is actually exothermic. For example, it's 200 kilojoules per mole energy comes out. The negative sign tells you it is an exothermic reaction. If you increase the temperature, this is temperature. If you increase it, if you increase the temperature, this is my advice to you to understand this. In exothermic reaction, so this whole reaction is actually exothermic reaction. You can see that if you increase the temperature, the reaction will go backward. Why? Because some of the energy is lost in the system, which means along with the product, you have made some energy. And by increasing the temperature, you are increasing the one of the product. If you take the energy as a product, it's very easy to understand. You increase the concentration of any one of them, the reaction will go in the opposite direction. So because you increase the energy, it will go backward. So when you increase the temperature in exothermic, the reaction will go backward. It will go backward. By increasing, temperature increases, it will go backward. In chemistry, they're not going to rely on your journal answer. You have to tell them the reaction will go backward or the left-hand side, and producing more, you will get more yield of nitrogen and hydrogen. Produces more N2 and H2. If you obviously decrease the temperature, the reaction will carry on the forward direction. So reducing the temperature or decreasing, if you decrease the temperature, it will go forward direction or right hand side, and you produce more NH3. It is an exothermic reaction. Now the second, if you want to write down, you can make that, you can screenshot, or you can just pause the lesson and you can write it down. Now, the second one is when you have endothermic reaction. If your reaction is endothermic reaction, for example, you have A plus B and you are making C plus B, which is completely an endothermic reaction. If you want to take an example, you can take an example that you have a NH4Cl making ammonia gas and chlorine gas. The forward direction is endothermic. You heat it up, that's why it makes ammonia and chlorine gas. The moment you're going to reverse it, it is exothermic. Let's just say the whole reaction, let's just not get into this. Let's just say this is an endothermic reaction. Endothermic reaction means you put the energy on the reactant side. Here, exothermic reaction was, the energy was actually used as one of the product. In endothermic, the energy, because you're going to heat it up, is one of the, if you have seen my previous video, energy is one of the reactants, because the reaction won't start if you don't put the energy in. Now, if you heat it up, the reaction will, so increasing the temperature, the reaction will go into the forward direction, which means more NH3 and Cl2. You remember, when you increase the temperature in the exothermic, you produce N2 and 3H2, means you produce more reactants rather the product. In this case, in endothermic, you produce more ammonia and Cl2. Now you have another situation, you're decreasing the temperature. What's going to happen here is, when you decrease the temperature, you are decreasing one of the reactant. So the reaction will go in the backward direction. When it goes in the backward direction, so you can say the equilibrium will be shifted, not the reaction, but you can say equilibrium will be shifted to the backward, and you will produce more yield of NH4Cl. You will produce more NH4Cl. And why is it happen there? Because the equilibrium has to achieve should be achieved when you actually make changes on each side, either because of the pressure, temperature, or concentration. I hope you understand it. One thing I want to make a point for the higher tier students: catalysts which actually increase the which decrease the activation energy of the reaction and make the reaction happen very quickly It is one of the factors where obviously you can see that the reactants, for example, is an exothermic reaction. It will happen at the low energy. If this is energy, you will see that the reactants requires very less amount of energy to convert into the product. That's the job of the catalyst, to obviously load the activation energy. Catalysts do not have an effect on the dynamic equilibrium or on the rate of reaction, especially in the reversible reactions. Why? Because you have forward and backward. So the catalyst will increase the forward direction, it will increase with the same rate in the backward direction. So that's why catalysts do not have any effect on the reversible reactions when they are in the equilibrium. I hope you understand that over time. Yeah. Right. Thank you very much.